project and all the visualizations are accessible from this link, and index.html is our main home page. And so based on this Stack Overflow dataset, we have done some pre-processing of data because the dataset was like in multiple files for the whole year 2014. So we have done some pre-processing using some MATLAB and Python scripts to combine the whole data into a single file, and then we have done a whole analysis, and all the visualizations are based on the combined dataset. So we have done a couple of visualizations. The very first part that we started with was a text analysis. So we did some text analysis and printed out the top 50 or top 60 packages or topics discussed in the Java dataset. So we did all this based on the tags column in the dataset. So after we have we know all the packages that were discussed in this dataset, we visualize them in a form of a bubble chart that is under this tab, top packets, and then the next analysis is doing some monthly analysis for those topics. And after that we did some one more time series analysis, that is weekly analysis of all the activities corresponding to each package, like each popular package. And then we did some analysis based on user ID as well, that is we have visualized the top users, their activities corresponding to the popular topics, popular package, how active they are corresponding to those packages. And then we did one more time series analysis to visualize the number of votes corresponding to the activity of a specific user. And we have provided an option as well to view the whole profile of that user, where he's located, how many questions he has answered, and all those things. And at the end we built one classification model as well in order to classify a day of the week as a high active or a low active day. So the very first is under this tab, that is top packages, and we have visualized in the form of a bar graph, and it can be visualized that Android is the hottest topic, and it was discussed with this count 99814, and the size of the bubble is based on the number of times that topic was discussed. Clicking on a different topic, let's say spring, it will come to the center, and so its count is 44136, and in this way all the popular topics were visualized here. So after doing text analysis, we have done monthly analysis, that is one more time series analysis to analyze the activity corresponding to each package over the year 2014. So we have represented this visualization in the form of stack bar graph, where each part of the graph has three parts. The top part is the number of questions, the middle one is the answers, and the bottom one is the accepted answers. So all the popular packages going from Android to JSON are represented in the form of bars. If you hover over a particular slice of this stack graph, then it should show a number, that is the number of times, that is the number of activities corresponding to this package. That is the top one is the questions, the middle one is the answers, and the bottom one is the accepted answers. So you can hover over any part and you can see the number. So the trend is almost same for all the packages, that is the activity decreases if you go towards the end of the year, and it is maximum at the very beginning of the year, or you can say first quarter of the year. So the reason might be because at the end of the year we have a festival season, so the active users are enjoying their holidays or something else, and they are not asking too much questions or answering too much questions. So the trend was almost similar for all the packages except for a few, like swing, which is competing with spring. Like if you switch over a different month, then you might see that sometimes they both are same in terms of number of responses, or sometimes spring is up or swing is down, or something like that. So you can change month from this drop-down menu and have visualization for any month of year for the year 2014.
Now we'll be discussing the weekly activity analysis. This is basically a sunburst. It has hierarchical data. The first level of the data will show you the day of the week. The second level will show us the type of data, like type of the query, whether it's a question asked, whether it's an answer or an accepted answer. The third level will show us the distribution corresponding to each package. So it will show us the package or tag corresponding to that question, answer, and accepted answer. That whether the question belongs to Android, Spring, Hibernate, or any other package. So what we can do is we can click on the day and activity package and hover to view stats. So we can use the hover to see the percentage in that specific visualization. So suppose if we take in consideration this Android field in Wednesday. So this percentage of Android is given among all the different packages, and suppose the percentage of Android questions asked on a Wednesday will be 1% among all the different packages. So what we can do in this also is we can click on any of these days or any of this field. So we can suppose click on Wednesday. Now this will give us the distribution for Wednesday, or the question asked, answers, and accepted answers. You can see the percentages have changed. Now it's giving the percentages related to the posts on Wednesday. So like 44% of the queries for Wednesday were questions, 37 were answers, and 19 were accepted answers. Now if we again consider the Android field on a Wednesday, Now it's 6%, so this will show us that the Android question asked on a Wednesday will be 6% of all the queries asked on a Wednesday. You can also notice that some of these labels are visible now, which were not visible in the earlier field. Like suppose we consider this Wednesday, we cannot see swing here or Maven or anything because the size of the slice is too low and labels could get jumbled up. So what we have done is if we clicked on a Wednesday and we get a big enough slice, we are showing them. So if the slice is not big enough, to avoid any confusion, we are ignoring it. And now what we can do is we can again click on accepted answers to look at its distribution. You can see now JSP and JS1 are also visible because they have a bigger enough slice, and this will give us the distribution of all the accepted answers on a Wednesday and the distribution of the different packages that accepted answer was based on. So we can use it to determine the trend, like how it's varying with the day of the week. Like in this case, we can see the Sunday and Saturday about 9%. So the activity on a Sunday, on a weekend, to Sunday and a Saturday is less than the rest of the days, and it's highest on a Wednesday, see 17%, and then 17% on Thursday. It's highest on the mid of the week, so we can see that the trend is shifting from mid of the week towards the weekend. So it's highest at the mid of the week and least at the weekend. So we can use this graph to figure this out. Like we can also find out that the highest here is Android because it's visible. So we can see the highest topic on each day. It's basically Android. So we can use this sunburst basically to look for certain trends and how these type of query and the topics is varying with respect to the day of the week.
In this visualization, we have shown the relationship between the top user ID and the top tags. Top tags has been derived earlier from the text analysis we have done. So we have taken the top 50 tags and placed it on the circumference. And we have placed the top user ID derived from the number of activities in the center. So if we hover on any of the user ID, we can see the relationship between the top tags and top user ID. We can see that the top user is related to most of the top tags. So we can derive like that the top user ID is actively participating in topic discussion in Stack Overflow. And moreover, if we hover on further, we can see how the relationship varies. And if we click on any of the user ID, we can see the user profile. So we have got this basic profile from Stack Overflow API, and we have also derived the easy reputation percentage derived from the user reputation divided by the top reputation in the data set. Also, we can see the user post statistic, like how many questions he has asked and how many answers he has given and how many have been accepted answers. Moreover, we can see like the top user doesn't ask much question and he gives mostly answer, and we can see the top statistics of the top user, and we can see like how this post vary on answer and accepted answer. Also, we can have placed the time series analysis of votes given on its post and with the time, and we can see from the time series analysis that the user ID is much active over the year, and he has received only one negative votes here, and mostly he has a good reputation because he has received mostly positive votes, and that's why I think so he has a good reputation. So we have done one more thing, that is we have built a classification model, that is support vector machine classification model, in order to classify a day of the week as a high active or a low active day. So what we did here is, first of all, we did some pre-processing of the data and labeled a day of the week as 0 to 6. 0 specifies Sunday, and if you go towards the top, then 6 is Saturday, 5 is Friday, and so on. So we have labeled each day of a week as high active or low active day based on the median of the whole data set after pre-processing. So then we trained this SVM classification model based on the number of posts for that day and the day of the week. So at the end, we got this decision boundary where all the crosses are the support vector and the circles are basically the data points. So we have plotted the data points against the model that we trained, and so it can be visualized that most of the points at the mid of the week, let's say at day 2, day 3, or day 4, at the high end, in the high region. But if you go towards day 6 or day 0, that is Saturday or Sunday, so most of the points that is circle are here in the low region. So this model can be used to classify given day of the week and a number of posts on that day as a high active or a low active day based on this decision boundary.